SpaceXInvestor. Not financial advice.
Reports say Tesla may demonstrate a radically redesigned Roadster using cold gas thrusters developed with help from SpaceX. One account even describes a remote-controlled stunt at SpaceX's McGregor test site. That sounds like a flying car. It is also not an official product announcement. Tesla's own Roadster page still advertises the familiar headline numbers: 0 to 60 in 1.9 seconds, a top speed above 250 miles per hour, 620 miles of range, 4 seats, and a removable glass roof. Its latest quarterly update lists the program as design development. So, the real story is not that Tesla has confirmed a customer car that can fly. The story is that credible reporting points to a serious engineering demonstration, while the public evidence still leaves the partnership, the hardware, and the production plan unproven. Today, we are separating 3 lanes: what Tesla and SpaceX have confirmed, what recent reporting claims, and what remains speculation. Then we will ask the investor question: would a Roadster with rocket technology become a meaningful business, or the most expensive halo product Tesla has ever built? Start with the official car. Tesla revealed the second-generation Roadster in November 2017. The prototype was a low, 4-seat electric sports car with 3 motors, a 200 kilowatt-hour battery pack, and extreme performance targets. The original production goal was 2020. That date passed. The design has remained on Tesla's website while the company shifted capital and attention toward Model Y, Cybertruck, artificial intelligence, robotics, energy storage, and the Cybercab. In Tesla's second quarter 2026 update, Roadster appears in a product table with a 2-word status: Design Development. That wording matters. It is not pilot production, factory commissioning, or customer delivery. Tesla also has not added cold gas specifications, a SpaceX edition, a new price, or a dated demonstration to the official Roadster page. Now compare that with the reported car. According to reporting summarized by Electrek and We Talk Tesla, teams at Tesla and SpaceX have explored a cold gas system internally called A71, demonstrated an early version to Elon Musk, and considered a public event in August or later. Those details may be accurate, but until Tesla or SpaceX publishes the hardware and the test conditions, they belong in the reported lane, not the confirmed lane. The timeline explains why that distinction is necessary. In 2017, the Roadster reveal created an extraordinary benchmark: supercar acceleration, hypercar speed, and long electric range in one package. Production was initially targeted for 2020. In later years, Musk repeatedly revived the program with promises of a more dramatic design and a SpaceX option package. Yet the public status remained development rather than production. The result is a 9-year gap between reveal and the latest reported demonstration plan. A long development cycle does not prove the project is fake. Low-volume halo cars can wait behind higher-volume programs, and a major redesign can reset engineering work. But the delay changes the standard of evidence. A new stage presentation is not the same as a validated prototype. A prototype is not the same as a certified production vehicle. And an unforgettable acceleration run is not the same as a car customers can insure, recharge, service, and drive legally. For investors, the correct response is neither automatic belief nor automatic dismissal. It is to identify the next proof point and refuse to skip the steps in between. Cold gas propulsion is real, established engineering. NASA describes the basic mechanism simply. Stored gas is released through a nozzle, and the expelled mass produces force in the opposite direction. There is no combustion chamber. The system can respond quickly, use relatively simple hardware, and provide precise control. Small spacecraft have used cold gas systems for attitude control and short maneuvers. On a car, strategically placed nozzles could theoretically add force during acceleration, braking, or cornering. That is very different from saying a Roadster can sustain flight. The vehicle has to carry tanks, gas, regulators, valves, plumbing, nozzles, sensors, and protective structure. Every component adds mass and consumes packaging volume. Once the stored gas is depleted, the thrust is gone until the system is recharged. NASA's reference material highlights the core trade-off. Cold gas is simple and mature, but storage and total impulse limit what it can do. There is another physics distinction. Helping the tires accelerate the car requires far less continuous force than lifting the entire vehicle against gravity. A short burst that improves a launch could be technically impressive without producing anything that resembles normal flight. Until Tesla discloses tank pressure, propellant, nozzle geometry, duration, vehicle mass, and repeatability, any precise performance estimate would be guesswork.
Here is the reported package with the attribution kept visible. The information, as summarized by Electrek, reported that the internal effort used the name A71, that Tesla and SpaceX personnel worked on the cold gas system, and that employees presented an early demonstration to Musk. The same account said the public demonstration had moved to August or later. A later summary from We Talk Tesla described a possible event at SpaceX's McGregor, Texas test site, remote operation for the most aggressive stunt, and a limited SpaceX version alongside a more conventional Roadster. None of those details appears in Tesla's latest quarterly update or on its official Roadster page. Remote operation would also be logical, even if the report is accurate. It could protect a driver during an experimental high-force test and allow engineers to demonstrate a capability that would not be legal or appropriate on a public road. But it would also narrow what the test proves. A remotely operated prototype on a controlled pad can establish thrust, control, and spectacle. It cannot establish occupant safety, street certification, production reliability, or customer usability. Watch the demonstration if it happens. Just read it. The production version would face at least 6 hard questions. First is crash safety. High-pressure storage and external nozzles would have to survive impacts without creating new hazards for occupants, responders, or nearby vehicles. Second is capacity. How many maximum force events can the system deliver before recharge, and what equipment performs that recharge? Third is thermal and structural loading. Even without combustion, rapid gas expansion, valves, mounts, and the vehicle body experience forces that must be managed repeatedly. Fourth is control. Extra thrust has to coordinate with traction control, steering, braking, stability software, tire grip, and road conditions. Fifth is the environment around the car. Noise, dust, debris, and jet direction matter on a test pad and matter even more near people. Sixth is regulation and insurance. A spectacular capability can be prohibited on public roads or disabled in customer software. These challenges do not make the concept impossible. SpaceX has deep experience with propulsion, pressure systems, controls, rapid testing, and safety operations. Tesla has deep experience integrating power electronics, vehicle software, and high-performance drivetrains. The collaboration is technically plausible. But the more extreme the public claim becomes, the more evidence is required. The decisive demonstration is not one astonishing run. It is a repeatable system with disclosed operating limits and a credible path through certification, manufacturing, service, and customer use. Tesla and SpaceX already have real, documented connections. In 2018, Falcon Heavy's first flight sent Musk's original Tesla Roadster and Starman into an orbit around the Sun. The image became one of the most memorable product and launch crossovers ever created. In 2026, Tesla also disclosed an approximately $2 billion equity investment in SpaceX made during the first quarter, followed by an unrealized gain in the second quarter. That is a financial connection. It is not evidence of a Roadster development contract. The companies also share Musk's leadership and can benefit from talent, knowledge, and supply relationships. But investors should not turn proximity into proof. Falcon Heavy history, common leadership, an equity stake, and broader manufacturing ideas do not automatically confirm that a production Roadster will contain SpaceX hardware. The clean standard is public documentation, a joint announcement, named hardware, disclosed responsibilities, or a prototype both companies identify. Until then, the cold gas collaboration remains reported, even though the broader relationship is unquestionably real. The bull case is powerful, even if Roadster volumes remain small. A credible demonstration could generate global attention at a fraction of the cost of conventional advertising. It could restore Tesla's image as the company willing to attempt technology other automakers will not. It could showcase useful knowledge transfer between Tesla and SpaceX, attract engineering talent, and create a premium halo above the rest of the lineup. The bear case is just as clear. The program has missed its original timing by years. A cold gas system could add cost, mass, service complexity, certification risk, and distraction, while contributing little near-term revenue. A controlled stunt can win the internet and still never become a customer feature. So watch 5 signals. 1. A dated announcement on an official Tesla or SpaceX channel. 2. A physical prototype shown continuously from multiple independent angles, not only a render or edited highlight. 3. Disclosed tanks, valves, nozzles, propellant, control logic, operating duration, and safety limits. 4. Production tooling, suppliers, price, certification, service, and delivery information. 5. Repeatable tests, not a single remote-controlled run. My verdict is balanced. There may be serious engineering behind the reports, and even a limited thrust-assisted Roadster could be extraordinary. But a formal production partnership and a customer car that can truly fly are not confirmed. Treat the demonstration as evidence when it arrives, then ask what it proves. Subscribe for the source documents and operating data behind the headline. This is SpaceXInvestor.